Hello, this is the first in a series of videos, no pun intended, about whether numeric series converge or diverge. Now, before we get into that, let me remind you what that means. A numeric series converges if you take all of the infinite terms, add them together, and they add up to a finite value. An infinite series diverges if, when you add up the terms, you get infinity, or negative infinity, or you bounce between, or any number of other things. But converge means you keep adding those numbers together and get towards some finite sum. Now, we've talked about this once before, and we've talked about numeric series in the beginning as geometric series. And we came up with a rule, so just a reminder, if you notice that something is geometric and you know that your common ratio is between 1 and -1, that geometric series converges. What does it converge to? Well, those terms are going to add up to a over 1 minus r, where a is the first term and r is the common ratio. When your common ratio is greater than or equal to 1 or less than or equal to -1, that geometric series diverges. No ifs, ands, or buts about it. So if I come down here and said, all right, here's some series. Are they going to converge or diverge? I'm going to write out the first couple of terms and just see what they look like. So if I start with n equals 1, I would have 3/4. When n equals 2, I'd have 9/16. When n equals 3, 27/64, and so on. And I'm going to look at that and say, is that geometric? Yes, this is. This is geometric. R is equal to 3/4. 3/4 is between 1 and -1. Therefore, the sum of this series is a over 1 minus r. And if I multiply the top and the bottom by 4, I get 3 over 4 minus 3, which is 3 over 1. So this series converges, and the sum is 3. If I look at the next example, a little bit more complex, it's still exponential, so it feels like it's geometric. Let's test it out. So if I plug in n equals 1, I would have -2 times 5/4 squared, which is 25/16. When n equals 2, -2 squared is 4, and 5/4 to the third, which is going to be 125/64. These numbers are going to get big. And then when n equals 3, this is going to be -8, and 5 to the fourth is 625. 4 to the fourth is 256. Okay, feels geometric. What am I multiplying by each time? Well, -2 became 4 because I multiplied by a -2, and I multiplied by a 5/4. So my r is -10/4. It is geometric. I could find r, but r is not between 1 and -1. Therefore, this diverges. Ta-da! Now, that was all well and good, but what if it's not geometric? Then what? Now we learn new rules for that. So the first test is the nth term test for divergence. This test will prove whether something diverges or if it has a chance to converge. This test does not ever prove convergence. It only proves whether something diverges or alternately has an opportunity to converge. So here's what it says. If either the limit as n approaches infinity of a sub n does not equal 0, or this limit does not exist, then the infinite series diverges. What? Here's what that meant. It means for a series to have a chance at converging, the terms must approach 0. That's why it says if the limit doesn't equal 0, it diverges. So for a series to have a chance at converging, the terms must approach 0. If the terms approach anything other than 0, or you can't figure out what the terms approach, it has to diverge. But if they go to 0, all you know is it might converge. Okay, so when we come down here, let's see. This says n equals 1 for this. Whoa, that's weird. I'm going to plug in some values just so you can see what this series looks like. So if n equals 1, this is going to be e over 9. And if n equals 2, it's going to be e to the 1/2 over 19. And then I'm going to have, when n equals 3, e to the 1/3 over 29. Okay, Well, the bottom is getting bigger and the top is getting smaller. This fraction is reducing. Now, is it reducing to 0? I'm not sure. So what I'm going to do is I'm going to take the limit as n approaches infinity of e to the 1 over n over 10n minus 1. And if I have e to the 1 over infinity, that's like e to the 0, which is 1. And if I put infinity on the bottom, 10 times infinity minus 1 is infinity. And 1 divided by infinity is 0. So this has a chance to converge. Okay? But I don't know if it does. If I come over here to the next one, I have, let's see, n equals 1, 6 over 4n minus, 6 over 4n minus 1. If I plug in n equals infinity in here, I have 6 over 4n minus 1, which is going to be 6 over infinity, which is 0. This has a chance to converge. And I actually want to add one more onto here. So add this last one. There is supposed to be one here. Maybe it's on your screen if I fix it before you watch this video. So this may already be on your screen. What if I had the summation for n equals 1 to infinity of 5n minus 2 over 26n plus 12? Well, if I look at that, as n approaches infinity, this is 5n minus 2 over 26n plus 12. And if n approaches infinity, this goes to 526. 526 is not 0. That means that as the terms go further and further out, they start to approach a value of 526, which means I'm adding 526 plus 526 plus 526 plus 526. That's going to add up to infinity. I can't stop it. So since 526 is not 0, this diverges. End of story. Okay? So there is page 1 in our convergence notes for numerical series. Come back again later for page 2.